All right, today, lesson 33A, parallel and perpendicular lines. This is officially the last new lesson for Unit 2. So after today, we start getting ready for the Unit 2 test. And I'm not really sure when that will be yet, but I will certainly let you know in the next day or two. And, all right, so here's what I would like you to do. I would like all of you to take and graph both of those equations on the same coordinate plane. You do have a coordinate plane in your notes, so graph both of them. And you need to make sure that your graphs are extremely neat, which is why I passed out rulers, so please use your rulers. As soon as you finish graphing, what I want you to do is I want you to look at the graphs, I want you to look at the equations, and I want you to list all the things that you notice. Because I'm about to have you get together with your shoulder partner, and you're going to talk about all the things you notice, about your graph, about the equations, and so on. So what are some of the things that you notice? There should be two things in particular.
I noticed that they're parallel.
When you graph them, you have parallel lines, all right? What else?
They have the same slope.
They have the same slope. And so what that should lead us to believe is that every single time that we have two graphs with the same slope, or two equations with the same slope, their graphs will result in two parallel lines. And that is exactly true. And so as I finish it, we have parallel lines, and with regards to the equations, they have the same slope. They have different y-intercepts, but they have the same exact slope. So somewhere in your notes, if that is not written down, you need to write it down. Parallel lines have the same slope. Because one of our goals today is to write equations of lines that are parallel to each other. Now, if we look at my two lines, it looks like the red line is translated. Last year you should have talked about translations, and we will come back to them a little bit later in the year. But the red line is translated, shifted 2 up to form the blue line. So if we move the red line up 2 units, we have the blue line. Okay, so first official problem here. The question is whether these two lines are parallel or not. This problem is not in your notes. I want you to take a look at it. And I want you to turn to your shoulder partner and discuss whether they are parallel or not, and why that is. Question was, are they parallel or not? Are they?
Yes.
All right. Somebody tell me why they are parallel. They have the same slope. It may not look like it, but the one on the left, if you put that equation in slope-intercept form, which we have done hundreds of times so far this year, you can now see they both have a slope of -3. Therefore, they have to be parallel to each other because parallel lines have the same slope. All right. Next problem. Write the equation of the line in slope-intercept form that is parallel to y equals -2x minus 9 and contains 4, -3. 3 lessons ago, when we learned how to write equations of lines with the point-slope equation, I told you every single lesson afterwards we would need to utilize that, because I also stated that any time we're asked to write the equation of a line, that's what we would need to use. Well, in order to use the point-slope equation, we need a slope and we need a point. Well, since we are writing the equation of the line parallel to y equals -2x minus 9, we just take the same slope. Why? Because parallel lines have the same slope. So since the slope is -2 here, the same slope of that, which is the one that we're going to use, will be that same constant or coefficient, depending on how you look at it, which would be -2. So everybody now, find the equation of that line. All right, let's take a look at this. So we're using -2 for our slope, 4, -3 for our ordered pair. We substitute those in the right spots. Add the opposite on the left-hand side. Use the distributive property on the right-hand side. Make sure that it's in slope-intercept form. So we need to subtract 3 from both sides, and we should get y equals -2x plus 5. Any questions with that one? All right, let's go to the next problem. That one was easier because the slope was an integer, but sometimes we have slopes that are fractions, like in this problem. Find the equation of the line parallel to the line y equals 4/5 x minus 7/5 that passes through negative 3 comma 7. Parallel lines have the same slope. Slope we are using is 4/5 because parallel lines have the same slope. Ordered pair is negative 3 comma 7. Substitute those into the point slope formula or the point slope equation, whatever you want to call that. We end up with this. Add the opposites on the right hand side in the parentheses. Use the distributive property. And then of course this is where people, a few of you, struggle a little bit, adding 7 to both sides. So I went ahead and turned the plus 7 into 35 over 5, finding the common denominator. And we should end up with y equals 4/5 x plus 47/5. Any questions there? All right. Next problem. Find the equation of the line in slope-intercept form that is parallel to 3x minus 5y equals 10 and contains negative 2 comma 6. Parallel lines have the same slope. What's the slope of that line? Well, I heard a bunch of things. I did hear somebody say 5, I think. How do you know? How do you know what the slope is for that line? In other words, what are you going to have to do to find the slope of that line? Put it in slope-intercept form. So do that. Let's put it in slope-intercept form. We have to solve it for y. And I know when I asked for that question, some of you quickly did that in your head. If you're going to do that, just be careful. But you need to put it in slope-intercept form before you can find the slope. So now tell me, what is the slope of that line? Say it. 3/5. There we go. We have to subtract 3x from both sides, divide everything by negative 5, and we end up with y equals 3/5 x minus 2. Parallel lines have the same slope, so we use 3/5 and the ordered pair negative 2 comma 6. Now, find the equation of the line that is parallel to 3x minus 5y equals 10. All right, so we're using 3/5 for the slope, negative 2 comma 6 for the ordered pair. Substitute those into the point slope equation. Use the distributive property, and now we need to add 6 to both sides. When we do that, we're going to have to find a common denominator, and it ends up looking something like this once we add 6/5 and 6. So it should be y equals 3/5 x plus 36/5. Any questions with that one? And this is the first problem where I've kind of skipped the work on how to do that, but you know what? This is honors 8th grade. I shouldn't have to show on every single problem how to add a fraction and a whole number. That ends up being that part right there. Okay, so that's parallel lines. Now we have this problem. I would like you to graph both of those two equations on the same coordinate plane and list all the things that you notice. They are. So when we graph both of these, and I don't know how I got to there. Let me back up there. Oh, I hit the arrow by accident. So we graph one right on top of the other. And in fact, they are perpendicular to each other. So the next question is, well, why are they perpendicular to each other? Well, when we take a look at their slopes, they are what we sometimes call opposite reciprocals. Both those things at the same time. The reciprocal to 2/3 is 3/2, and then the opposite of that is negative 3/2. So we can call them or think of them as opposite reciprocals, or another way of thinking about it is that if we find the product between those two slopes, the product is -1. So you've got some blank spots that you need to fill in your notes right now. So once again, perpendicular lines have slopes that are opposite reciprocals to each other. For some people, it's easier to remember it that way. For other people, it's easier to remember that we're checked by multiplying the slopes, and that product is supposed to be -1. So if we're asked to find equations of lines For perpendicular lines, that's our thought process. We have to do opposite reciprocal or think of a number that will create a product of -1. All right, so backside. 2/3. Let's go through this very quickly. What is the opposite of 2/3?
-2/3.
What's the reciprocal to 2/3? And if we put those two things together, the opposite reciprocal would be -3/2. So let me go through the rest of this really quickly. The opposite to -4/5 is 4/5. But the reciprocal to that is -5/4. If we kind of think of those two things at the same time, the opposite reciprocal to -4/5 is 5/4. These are the thought processes that we need to go through to figure out the slope that we need for perpendicular lines. The opposite of 3 is -3. The reciprocal to 3 is 1/3. Thinking about both of those things at the same time, the opposite reciprocal to 3 is -1/3. For 0.2, the opposite of that is -0.2. But the reciprocal to that, now we have to think of it as a fraction. That would be 5. And if we piece those two things together, the opposite reciprocal to 0.2 is -5. And for -8, we end up with this. The opposite reciprocal to -8 is 1/8. So to the right of that, in your notes, we are trying to determine whether the slopes result in perpendicular lines. So for number 1, perpendicular, yes or no? I heard one person say no, and the rest of you say yes. Are they opposite reciprocals, yes or no?
Yes.
Or you think of the product. The product of those two, 2/3 times -3/2 is -1. Either way, whatever it takes for you to understand, those are perpendicular. How about number 2, perpendicular, yes or no?
No.
No. The thing that messes it up is they're both negative. So while they're reciprocals to each other, they are not opposite. Or if you multiply them together, you get +1, not -1. Number 3, perpendicular or not?
Yes.
Yes. They are opposite reciprocals, or if you find the product, you get -1. Whatever it takes for you to understand how to find the slope of something that would be perpendicular to something else. All right. Next problem. Write the equation of the line perpendicular to the line y equals -3/2 x plus 9/2 that passes through the point 2, 5. The first thing we need to think about is what is the slope that we are going to use. Quickly, talk with your shoulder partner. What slope are you going to use for that one? All right, Morgan, what slope are we going to use? 2/3. That is the opposite reciprocal to -3/2. Now, there's a shortcut way of writing perpendicular. Everybody look up here, please. When you see an upside down T like that, that represents the word perpendicular. Okay? So we're going to use 2/3. All right, you take it from there. Find the equation of the line that's perpendicular to y equals -3/2 x plus 9/2 and goes through 2, 5. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals to each other. All right, we're using 2/3 and the order pair 2, 5. We use the point slope equation, and that results in this. Use the distributive property. And one thing that I saw from a couple of you is when you added 5 to both sides, which is 15/3 because we'll have to find the common denominator, a couple of you failed to realize that that is a -4/3. If you don't believe me, add the opposite. So it's not plus 19/3 at the end, it's plus 11/3. So don't miss the signs right there. So the equation is y equals 2/3 x plus 11/3. All right. For time purposes, here's what I want you to do for the next two. You don't have to come up with the equation. All I want you to do on the next two problems is come up with the slope that you would use, because both of them are, neither one of them are in slope-intercept form. So you will need to put it in slope-intercept form first so that you can figure out what slope you would use. So once again, for the next two, I don't want you to find the equation, I just want you to find the slope that we would use. I'll give you about a minute to do that, and then we'll compare with our shoulder partner. The only way that we can find the slope that we need is to put this equation in slope-intercept form and then find the opposite reciprocal to that. So we would need to add x to both sides and then divide everything by 4, and now it is in slope-intercept form. Y equals 1/4 x plus 3/2. The opposite reciprocal to 1/4 is -4. That's the slope that we would need to use. And I know that I went ahead and finished it off here, but I didn't ask you to do that. Why don't you go ahead and write what that equation is, just so you have it in your notes. All right, in the next problem, I asked you once again to only find the slope. So once again, we need to put it in slope-intercept form. It is now in slope-intercept form. That's the slope of that line. The opposite reciprocal to that, which is what we need for perpendicular lines, would be positive 5/3. I'll go ahead and finish that one off. And that's what it would be. Y equals 5/3 x minus 4/3. All right, so a quick summary here, and then the last thing for today. Summary. Parallel lines have the same slope, like these two. Perpendicular lines have slopes that are opposite reciprocals, or in other words, they have a product of -1, like these two right here. Okay, here's the first of the two shapes that are in your notes. The question that I have for you, and this is the kind of problem that you're going to see next year, which is an extension. Just leave it back there. How could you prove that that is a parallelogram? How could you prove that? Turn to your shoulder partner, and by the way, it has something to do with what we just talked about. Turn to your shoulder partner and quickly talk about that.
Parallelograms have two sets of parallel lines, so you make sure they're parallel by comparing the slopes.
Exactly, comparing the slopes. So this is supposed to be I didn't mean to click that. This is supposed to be parallel to that. It's a parallelogram. If you find the slope of each, they better be the same. Parallel lines have the same slope, and the same thing with that side right there and that side right there. Okay? Now, let me go ahead and bring up the blue triangle. How could you prove that that is a right triangle? Same thing. Quickly talk about that with your shoulder partner. There you go. So if we take this side and this side, that's where the right angle is supposed to be. Make sure that the slopes are opposite reciprocals. In other words, make sure that they have a product of -1 for the slopes. Okay, we are finished for today.